Hello and welcome to another one of these ADD videos. Today we're going to be discussing graphing sine and cosine. Alright, so the general formula for this type of graph is going to be this format here, in which you have A, and then in the box here we're going to have either a sine or a cosine. Okay, it doesn't matter which one, these rules still are the same. The only thing that's different is the basic pattern of the graph. And then the bx plus c. So there are a few things that you should know right off the bat. The amplitude, that's how far away from the x-axis the function goes. The frequency, that's how many complete fundamental cycles are there between the normal 0 to 2 pi range. So, and then there's period, which is the distance it takes for one fundamental cycle to repeat. What is this word I keep using? Fundamental cycle. Well, it's basically one turn of the graph. Okay, so here for the sine, it would be just this right here that you see, back to axis, peak, axis, trough, back to the axis. Okay, so just this portion right here. I'm not sure why it's not letting me draw on here. Let's see, there we go. So just that portion right there. Or for cosine, it'd just be from here to there. Okay, so when we add a coefficient to your x, it increases the number of fundamental cycles you'd have in that range between 0 to 2 pi. That's why it's called the frequency. Phase shift is going to move it left to right, and what I recommend you do for that one is you just take your bx plus c. Oh, that didn't look good, did it? Take your bx plus c here, set it equal to 0, and solve for x. That'll tell you which way to move left to right. Okay. The main thing you need to recognize here is that your pattern for sine starts at the axis, then is a peak, then the axis, trough, then peak. Whereas cosine starts at the peak amplitude and then goes to the axis, trough, the bottom amplitude, axis, back to the peak. All right. So what are the steps? How do I graph these things? All right. The first thing you want to do is go ahead and find all these guys that I just gave you the formulas for: amplitude, frequency, phase shift, and all that. But then the next thing you do is you set up this little inequality here. Okay. Your fundamental cycle is going to be between 0 and 2 pi. But if we add that's if it was just x in here. If we add a transformation of bx plus c to it, then what happens is the beginning point and the end point is no longer going to be 0 and 2 pi. So you solve for x to get what those two endpoints are. So the first one will be the beginning of the fundamental cycle, and the second one will be the end of the fundamental cycle. And when you take the difference between number 2 and that should be a number 1 right there, I guess I erased the subscript, it should equal the period. This is a good way to check it. So take this answer minus this answer, and you better get your 2 pi over b. If not, you did something wrong. Then you're going to take your period and multiply it by a fourth and repeat it a few times. So let's see one in action. This is a little bit easier to just do. Usually I separate the examples and concepts, but in this case it's easier just to show you. So there's your phase shift, there's your amplitude, this is your frequency. Take your 2 pi, divide it by your frequency to get the period. Set your 3x plus pi equal to 0 to get your phase shift. Set up this inequality here, always 0 and 2 pi on the ends if it's sine or cosine. Solve for x, and then this is the beginning of your fundamental cycle, this is the end. Okay? And if you take the difference, pi over 3 minus negative pi over 3 is indeed 2 pi over 3, because the negatives become a positive here. Two negatives become a positive. So then what you do is you take your 2 pi over 3, which was your period, multiply it by 4, because sine is broken down into 4 different sections, so is cosine. And when you reduce, you get pi over 6. So what you do is you start with this number 1 here, and you add pi over 6 to it 4 times. When you do so, your final answer better be this number 2 of pi over 3. In this case it is. Okay? So the first one, because this is a sine graph, if you remember from the top of the 3 sine 3x. Sine starts on the axis, then it goes up, then goes back down. It follows this pattern unless there's a negative sign in front of it. So in this case, this graph would look something like this, just a quick rough sketch. Let's see. So this is on both the negative and the positive end. So we would have the points of negative pi over 3, negative pi over 6, 0, pi over 6, and pi over 3. And it's on the axis here, goes up to the peak amplitude of 3 in this case, back to the axis, down, and back to the axis. So there's your one fundamental cycle. Whoa, got a little carried away there, sorry. Let's try that again. Take 2. And it would keep going in either direction. So this point was negative pi over 3, negative pi over 6, 0, pi over 6, and pi over 3. Okay? And these are these points here. That's where I got them. Every time I added pi over 6, that's how I knew what to put on the graph. So the only difference if it was cosine up there in the graph to begin with, I'll do it in blue. Cosine would have started at the peak, gone down to the axis, gone to the bottom amplitude of negative 3, back to the axis, and then back to your peak. So that would be your cosine graph if you were doing cosine in blue. So cosine, and then red was sine. Everything exactly the same as the original problem, and if that was a cosine, is what I did in blue. Okay? And the reason the amplitude was 3 was because of that coefficient. So you can see there's a lot to it. If you just practice a few of them, you'll understand how to do these. And you need to be able to do these pretty quickly. If you're asked to graph secant and cosecant, you have to do these first in order to graph those. So practice these until you got them backwards and forwards, and then you can move on to secant and cosecant. But if you got this, there's not much more to do to graph those two. I hope I've cleared up any confusion that you might have. Practice, practice, practice. Thank you, and have a nice day.